Hey everybody, Morgan here. Welcome back from spring break. We're going to take some time today to talk a little bit about the acid dissociation constant lab. Now, this was a lab where you were given two data points to work with. One was a 0.2 molar solution and one was a 1.20 molar solution. And the measured pHs of those solutions were 2.73 and 2.34. Now what I'm going to do is I'm actually going to provide a third trial, and this is going to be for 0.50 molar acetic acid, which has a pH of 2.53. And I'm going to do calculations today based upon that data. So, what's the Ka expression for this reaction? Ka is going to equal the concentration of the H plus times the concentration of the acetate ions divided by the concentration of the acetic acid itself. Now, if we were to set up an icebox to look at this, this would look a lot like x squared over the initial concentration, which in my example is 0.5, minus x equals Ka. So this times this, these two numbers are the same, divided by this, which is 0.5 minus x. So let's start off with trying to figure out how to mix up the acid itself. Let's imagine we're using 0.50 molar. Now, if this is 0.50 molar, using C1V1 equals C2V2, what we can say is to make 100 milliliters of the 0.5 molar, 0.50 molar times 100.0 milliliter equals 2.00 molar, which is our stock solution, right here, times X number of milliliters. So, solving that, X equals, I have 0.5 times 100 divided by 2 gives me 25 milliliters. So if I want to make 100 milliliters of this, I need 25 milliliters of the 2 molar and then 75 milliliters of water, because 100 is equal to 25 plus 75. Okay, now I know a pH here of 2.53. So the H plus concentration must equal 10 to the negative 2.53. Now, I'm going to run that through my calculator here. I'm going to go second 10 to the x, negative 2.53, and I'm going to get 0.00295. So my H plus concentration is 0.00295 molar. Now, the concentration of the acetate ion will be the same number, because these two form in a 1-to-1 ratio. If I was to make an icebox down here, I'm calling it the hydronium ion. You can call it the hydrogen ion. Doesn't really matter. So that's a minus x, this is a plus x, and this is a plus x. So what I end up with is 0.50 minus x, x and x. So these are the same. So those two have to be the same. So what is the acetic acid? Well, it's 0.5 minus x. So what I can do is take my 0.5 minus 0.00295 and get 0.4971. 0.497. And I'm adding in a few extra sig figs here. We'll round the correct number of sig figs when we get down here. Okay? So I can then take the data I've just calculated and plug it in to my Ka expression. My Ka expression equals 0.00295 quantity squared over 0.497, okay? So, clear this out, 0.00295 x squared divided by 0.497, and that equals 1.75 times 10 to the negative fifth. Now, since the pH goes to 2 places after the decimal, I'm comfortable giving this 2 sig figs, 1.8 times 10 to the negative fifth. Okay, so that's how we do this experiment. That's what this lab looks like, and that's due this week. I don't remember what day I put as the actual due date, Wednesday, Thursday, or Friday, but get that in as soon as you can so that we can move on to the next assignment. All right, hope you are all well. This is Morgan signing off.